Hi, myself Bhupati, belongs to Department of Mechanical Engineering and Sri Shanwa College of Engineering and Technology. Today's topic is steam nozzles. The nozzles introduction. A steam nozzle may be defined as a passage of varying cross section through which heat energy of steam is converted to kinetic energy. So the heat energy is converted into kinetic energy. Heat energy in the sense high pressure steam we are passing through the steam nozzle, it will be converted into kinetic energy. That means the velocity will be increased. Normally nozzle will be used for increasing the velocity. Major function is to produce steam jet with high velocity to drive steam turbine. Normally steam nozzles are used to drive the steam turbine. Turbine nozzles performs two functions. It transforms a portion of energy of steam into kinetic energy. So portion of steam into kinetic energy. In impulse turbine, it's direct steam jet of high velocity against a blade, which are free to move in order to convert kinetic energy into shaft energy. So due to momentum principle will be produced, the direction of flow will be changed. Due to that, the kinetic energy is converted into mechanical energy. Normally, the steam nozzle is applications in turbines, gas turbines, jet engines, rocket motors, and flow measurement, painting, etc. There are different types of nozzles: convergent nozzle, divergent nozzle, and convergent and divergent nozzle. In convergent nozzle, the cross-section area decreases continuously from its entrance to exit. For example, this is the convergent nozzle. This is the cross-sectional area. So this will be gradually decreasing to exit. It is used in case where the back pressure is equal to greater than the critical pressure ratio. Back pressure means outlet pressure. Divergent nozzle. The cross-section area of the divergent nozzle increase continuously. So this is the divergent nozzle. Here the cross-section area will be gradually increasing from inlet to outlet. This where the back pressure is less than the critical pressure ratio. Convergent divergent nozzle. In this case, the cross-section area first decreases from its entrance to the throat and then increase from the throat to exit. It is widely used in many applications of steam turbine. This is conversion. So the first half portion will be convergent nozzle and second half will be divergent portion. This is convergent and divergent nozzle. Then steam passes through the nozzle. The steam enters the nozzle with high pressure but with negligible velocity. In a convergent portion, there is a drop in steam pressure with a rise in its velocity. There is also a drop in enthalpy or heat of the steam. This drop of heat is not utilized in doing some external work, but it is converted into kinetic energy. So pressure drop. So the expansion process will be takes place in the nozzle. Uh, Pressure drop and the velocity will be increasing. In the divergent portion, there is a further drop of steam pressure with a further rise in velocity drop in enthalpy, converted into kinetic energy. So entry of the steam is high pressure and low velocity. Exit of the steam will be low pressure and high velocity. Back pressure means the steam which leaves the nozzle. So normally the thermodynamic process which involved in a nozzle is isentropic flow. So here there is no heat transfer and there is no work transfer. Then steam enters the nozzle with high pressure and low velocity and leaves with high velocity and low pressure. So outlet velocity is V2 can be found as follows. Here we are going to find out the velocity equation by using a steady flow energy equation, thermodynamic steady flow energy equation. So here we are represented V1 is velocity entrance, V2 velocity at exit, H1 and H2 will be steam entering and steam exit. The steady flow process, this is the steady flow energy equation. Datum energy G jet1 plus kinetic energy C1 square plus by 2 plus U1 is internal energy plus P1 V1 is flow energy plus Q heat transfer equal to G jet2 plus C2 square by 2 plus U2 plus P2 V2 plus work done. So as per the first law of thermodynamics, Q equal to W plus delta U. So the change in internal energy will be potential energy, kinetic energy, and flow energy. Here, the datum gets cancelled. Then U plus PV, as per the thermodynamic simplification, U plus PV means H. Here there is no heat transfer, there is no work transfer. So C1 square plus by 2 plus H1 equal to C2 square by 2 plus H2 plus losses. Then we'll take mass will be 1 because specific properties we are using. C1 square by 2 plus H1 equal to C2 square by 2 plus H2. So enthalpy difference H1 by simplification H1 minus H2 equal to C2 square by 2 minus C1 square by 2. So here we are multiplied with 1000 per kilojoule per kg is converted into joules per kg. So 1000 equal to C2 square by 2 minus C1 square by 2. Take the LCM H1 minus H2 equal to C2 square minus C1 square by 2 into 1000. This multiplication will become divide. Then 2000 H1 minus H2 plus C1 square equal to C2 square. C1 square plus 2000 into H1 minus H2. So we will have to find out C2. So square root of C1 square plus 2000 into H1 minus H2. Here, the inlet velocity is negligible compared to outlet. So C1 cancel. C2 equal to square root of 2000 into H1 minus H2. So square root of 2000 will be 44.72. So the C2 formula will be 44.72 into H2 minus H1. Thank you.